So in this video, we're going to continue on with vector functions and look at the indefinite integral. Of course, if we can differentiate vector functions, well, certainly it would be possible to integrate them. So the indefinite integral of the vector function r of t with respect to t essentially boils down to simply this calculation, as one would expect, the integral of rt with respect to t. And if we assume that capital R of t is the integral of rt, which means that dr dt, essentially dr dt is equal to r, okay, of t, just to note, then this is plus the vector position vector c. It's a constant vector rather than a variable vector or a vector function. So that's the indefinite integral. So for instance, an example, the integral of the helix that we saw earlier. So if we were to look at that in this notation, although as I told you, I'm not very keen on this notation myself, but of course it is a very handy and very frequently used notation. In any case, if we look at the integral of this, it turns out to be simply the integral of each component, and that basically boils down to the following. It's equal to sine t positive sine t plus, let's say, c1, okay, into I, okay, all of this will be multiplied by I, plus we'll have negative cos t, this is the integral of sine t, plus we'll call it c2 into j, and plus t squared over 2 plus c3 into k. So that would be our indefinite integral, and of course we can write it as sine t I minus cos t j plus t squared over 2 k, okay, plus c, where c is in fact c would be c1, c2, c3, the vector. So or the other or in, as I said, the shorter notation, which I personally prefer, is this one. C1, C2, C3. So that's the indefinite integral. Similarly, the definite integral AB of the vector function, of any vector function r of t dt is equal to, if rt is fgh, then it's simply the individual integrals. So it would become a to b of ft dt. The next component would be a to b gt dt, and the next would be a to b of ht dt. So essentially it's component-wise integration, and knowing the values of f, g, and h, we can calculate the integral from a to b. Now, the important thing to keep in mind is, I'll do an example of this one here. So here, if we were to calculate the r of t as an example, suppose we were looking at t squared, t cubed, and we were looking at integrating this from 0 to 1. So we were looking at this integral, for instance, 0 to 1 of t squared, t cubed, dt. Then that, of course, would be equal to the individual integrals. So it'll be t squared over 2 from 0 to 1, t cubed over 3 from 0 to 1, and of course t4 over 4 from 0 to 1. And once we calculate these, it's just going to be 1 over 2, 1 over 3, and 1 over 4 would be our integral. So it's reasonably straightforward, as you would expect.